Hello everyone. Today we are solving this problem, determine if two strings are close. So we are given two strings or two words because these strings have no space in them, and we are required to convert one word or one string into another string. And if it is possible to do so, then we will return true, otherwise we will return false. So in this sense we don't even need to convert actually, but we just need to check whether it is possible to convert one string into the another string or not. And to do this, we have two kinds of operation. Operation 1 says that we can swap any two elements or any two characters of the strings. For example, this is a character B and this is another character E, and I swapped their values, so I have this word now. Operation 2 says that every occurrence of one existing character can be changed into another existing character and do the same with the other character. So what this means is that how many instances of character A this string has? Three characters, right? One, this is 2, and this is 3. And how many B's does this string have? Well, this has definitely two B's. So if I change every occurrence of A with B and every occurrence of B with A, I have this string that is B, B, C, B, double A. What if I change every occurrence of C with B? In that case, I'll have A, B, A, C, C. So this is the second operation. That is, we can swap any two characters and we can transform every occurrence of one existing character into another character. Now this word here is very important, existing. This means that I can only convert A or transform A to C or maybe to B. There are no other possibilities. That is, I cannot convert A into Z or anything like this, which is not present in the given string. Another thing is that there is no constraint and we can perform these operations as many times as we want, any of them or both of them. So is it possible to convert one string into another? Let us see an example. So suppose this is the given string S1 and another string S2, and we are required to convert this string to this string. So how we are going to do this? Well, we are allowed to swap any two characters. I'll start by swapping these two characters, and therefore I'll have C double A triple B. After this, I can perform operation 2 on C and B, therefore changing all the occurrences of B to C and all the occurrences of C to B, and then I have double A here. Now I'll again do operation 2, and this time I'll make all the occurrences of B to A and A to B. Therefore I have the target string. Now this does not matter whether how many operations I perform to actually do this. It does not matter. All we are required to return is true, because yes, it was possible to actually convert this string into this string. So now maybe you should pause the video for a few seconds and see how this problem can be solved. Okay, so I hope that you have solved this question, and if not, then let's see the solution. So very important word in this operation 2 is existing. So if there exists any character which is not common in the two strings, then definitely answer is false. That is, if I had this string and instead of C, this C I had a D, in that case it is never possible to get rid of this D. And if we cannot do so, then it is also impossible to make this string which has no D. And therefore what we are required to do is to check whether every character that is present in this string is present in this string or not, or if there is some additional character in this string which is not present in this string. For example, if this had another character Z, then there was no possible way for me to actually generate or get this Z. So all we are required to do is to actually see if all these characters are common in both the strings or not. Now operation 1 says that we can swap any two characters. This means that if I have all the characters available, then I can always swap them to get them to the right place. One more thing is this, that the number of characters in each of these string, that is the number of unique characters, must be same. Again, let us take this example. So when we are actually transforming one character into any other character, what we are actually doing is interchanging the number of occurrence of each character. That is, if I have 3 B's and 1 C, then all I am doing in operation 2 is to convert one occurrence of C to actually 3 occurrences of it and construct the 3 occurrences of B to only one occurrence. Does this ring a bell? And if it does not, then see. How many C's I have? Only one. How many A? 2. How many B's? 3. And how many A I have in this string? A, B 2 and C 3. So this is for C, 2 is for A and 3 is for B. Here I have A, 2 is for B and 3 is for C. When I am actually applying operation 2, all I am doing is changing the number of occurrence of each character to the number of occurrence of any other character, that is flipping their occurrences. So I have C only one time and A two times. What I can do is to make C two times and A one time. So we try to do these operations so that we can get this string, and for this to be possible we need that these numbers are always same. They may be in different order and we'll sort them, or maybe not sort them, we'll just see if those two vectors are same or not to see if this is possible or not. Suppose if we had C here instead of A, then the values in this case would have been different. They would have been 2 and only 1 A and only 3 B's. In that case also I have the same number of integers, and therefore it is always possible to convert this string to this string. But what if I had one more C? In that case the number of C's would have been 3, and it was never possible to make 2 out of the available characters, because when C is replaced with A, I have 3 A's and only 1 C, and if I do so with B, then also the same thing happens. So what are my requirements? Every character that is present in one of these strings must be present in another string as well, and the count of each character, only their count, must be same. So this was the logic to solve this problem, and now let us see the solution. Okay, so I'll start by making 4 vectors to hold integers and 2 more vectors for unique characters present in the strings. So the next thing is int n is equal to word1 dot size, that is the size of the string or the word, and then I'll iterate over the word. Now word1 of I is a character, right? And what I want to do is to include the count of every unique character once I encounter it. It means that v1 of word1, that is this particular character, minus a plus equal to 1. That is, I am increasing the value stored there by 1. And what does this thing mean, word1 of I minus a? Well, I don't know what is the ASCII value of a, but whatever is the character here, suppose the character here is a, then a minus a is definitely 0. So if I have a in this place, then at the first location or 0th index, I am actually increasing the occurrences of a by 1 or occurrences of 0 by 1. And if there is some other character, suppose I have the maximum character which is z, then z minus a will be equal to 25, and this is the reason why I have taken the size of this vector to be 26. You can also use a map in the place of using these vectors. Now what I need to do next is to make sure that this character is present in the string, and therefore s1 of word1 I minus a is equal to true. That is, this character has appeared. I am storing this fact in the vector s1. Now the same things I am going to do for our another word, which is word2. So this time n becomes equal to word2 dot size, and here I replace word1 with word2, same here, here and here. Now I am required to sort these two vectors because they are storing numbers and not the occurrences. That is, the numbers how many times each character have occurred, and that needs to be the same, although the characters can be different. And all the characters are same or not is something that is being checked by these two vectors s1 and s2. So if so, I sort v1 dot begin comma v2 dot end, and similarly I sort, oh, here 1 and 2 here. Now I need to return v1 is equals to v2 and s2 must be equal to s1 as well. Accepted. So this is how you solve this problem, and the time complexity of this solution is order of n. Now you could be thinking why this is order of n and not order of n log n. In fact, we are sorting something and the time complexity of sorting is actually n log n, which is true. But the thing is that the size of our array that we have taken is always constant. It will never be greater than 26 no matter how big the given string are. And this is the reason that even sorting the array 26 log of 26 is a small number, so the most of the time is being consumed in parsing these strings and not in actually sorting these vectors. So this is the reason that the time complexity of this solution is order of n. So I hope you understood the logic to solve this question, and now I'll see you in the next video. Thank you.